Welcome to Key Shop, where we're continuing with part 2 of the Cyclone Separator design and build. And on this video, we're going to talk about some comparisons of units, as well as the goals that I set forth on designing the unit that I have. Then we'll get into talking about the build of the unit and do the top cylinder part in this video. Hope you enjoy it.
Okay, we're going to start with the goals that I set forth for designing and building this Cyclone Separator dust collector for my shop. I want to be able to collect dust and chips efficiently from my wood shop. Target goal of 800 cubic feet per minute of the unit. Minimum 600, but 800 is the goal. Target static pressure at that velocity, it'd be 6 to 7 inches water column. I'd like to use 2 Thien environmental nano filter canister filters with a total effective surface area of 440 square feet. And that's after talking with Thien about what filters I should use given that 800 cubic feet per minute. I'm going to use a current to Bridgewood blower. It's a 3450 RPM. The fan is 12.5 inches. Future, I'd like to upgrade to 14 inches, and I will actually do that towards the end of not this presentation, but in this series. Current motor is 2 horsepower. Likely going to have to increase that if I use a 14-inch fan, and I'll discuss that later. I plan to make the cylinder from 1/4-inch Lexan using 20 staves, and I just happen to have Lexan in hand of that thickness, so that's what I'm going to plan to use. I'll also talk about the alternative materials for the cylinder too. There's various types of units available for dust collectors. Some are more chip collectors, others are dust collectors. Up here on the left is a single stage unit by Grizzly. As it so happens, the 2 horsepower Bridgewood unit that I have is very similar to that. Sort of makes emptying the bags a real pain, and the filtration area isn't that great. They also make units with a pleated filter on the top, and so that increases the surface area for filtration, which is better, but you still have the cumbersome emptying of the bag at the bottom here. Plus, it doesn't separate things very well, and you can clog up the filter pretty easy up at the top. There are also 2-stage Cyclone units available, and I've just shown 2 of them here. The one is the Tempest unit, which is shown here, and has the drum filter at the bottom and cartridge filter over here at the right. And this does a much better job of pre-filtering the data before you ever get to the cartridge, so you're not clogging up the filters nearly as much. Then Jet and a number of others have also started coming out with slightly more compact units that are easy to move around and also empty the bin itself. And I sort of like the design. And again, filtration is pretty good on this prior to the cartridge filter unit. General comparisons: the single stage units cost a whole lot less than 2-stage units. They are less efficient, clogs filters faster because you're not separating the majority of the dust out prior to the filters. It's a small footprint, so for small shops this might be absolutely ideal for you. And medium height, so if you have height restrictions, it's a great solution for that. They are difficult to empty, and I've had some experience with that, plus bags blown off, and it makes a mess, blows dust everywhere. So from that aspect, you have to be really careful about making sure the bands that tie the bags on both the filter bag and the plastic bag at the bottom and some have a cloth bag at the bottom too, are really secured well so they don't blow off. The two-stage, like a Cyclone unit, they cost more, they are significantly more efficient. Clogs filter slower because you're removing most of the data, the media, whether it's chips or dust, before the filter. It is a larger footprint, and most of these units are tall, and many are too tall to put in a basement shop or a restricted area shop. Particularly if you're going to put a fairly tall bin at the bottom, they can be well over 8 feet tall to try to fit in. They are significantly easier to empty, and some of the units are more easier to empty than others, but definitely easier than the single stage unit. Typical Cyclone Separator examples, I've got two of them shown here, and I have no interest on either of the companies, so I'm not trying to plug one or the other. But the Clearview Cyclone, it's a clear unit that you can see what's happening inside. It's a really nice unit, has a ramped input on the input side, but it can be tall. And likewise with the Oneida Cyclone, I've heard nothing but good things about Oneida Cyclones too, and I'm not certain if this one actually converts and has a ramp inside of it or not. But again, these units can be tall, particularly if you're going to put a 55-gallon drum or some larger drum at the bottom of it. They can be well over 8 feet tall once you add the motor and blower assembly on top of it. They are very efficient units, but again, if your vertical space is you're limited in your shop, they can be a challenge. One of the reviews I've been looking at on how to build the various top hat separators, and there are a number of these videos out on YouTube, is it's really an attractive design where you have the input chips come in here inside a cylinder, and there's a gap around a drop slot around the edge. Now I've shown it all the way around. In reality, most of the fabrications that I've seen on YouTube, it goes on roughly around 2/3 of the way around. And this Thien baffle plate is at the bottom, so the chips come in, swirl around, and the chips go to the outside, and then the clean air comes out the top. And they look like they work remarkably well for such a simple unit. And I've got one here from Ghost's website or his YouTube site for building of this unit. Couple of things that I think they're not nearly as efficient as a Cyclone separator that I've shown on the previous page, in that when the air circumvents the circle here, when it gets back to here, any chips that are left here get blown back to the inside and have to swirl around again. So it doesn't seem quite as efficient there. It is fairly low profile though, and this particular one uses a 4-inch input and a 4-inch output. And if you remember on part 1 of the video, I really want to go larger. I want to do a 6-inch input and output for my dust collector, just to be able to get the volume up and keep the static pressure low. So the design that I've come up with is actually a hybrid of the two. I really like the efficiency of the top cylinder part of the Cyclone separator shown here, but hey, let's get rid of the cone part at the bottom, which is adds quite a bit to the height, and in there let's put a Thien type of baffle in it for separating out the chips, and let's see how that goes. It's a similar efficient performance, and as you'll see when we get to the very end of the testing of the unit that I've built, is extremely efficient, but significantly shorter than you would have with a tall Cyclone. two horsepower single stage collector that I bought used for $200. Again, it's a 12.5 inch fan in the blower unit, 2 horsepower here, and then it's got 2 cloth bags on it. And I'm not going to use the rest of it here. I'm just going to use the blower and the motor portion of this. And this is the initial drawing concept that I came up with for building this unit, where the Cyclone Separator is up in this range here. The air comes in with the debris in the magenta pipe shown here. It does angle down slightly, so when the air comes back around underneath the input pipe, it's not going to be running right into the side of it, and it should be a very efficient design, sort of similar to the Clearview approach on having a ramped input. I'll have the blower and the motor up on top with a plenum that goes over to the wind environmental filters, and I've got 2 of them there. And then I'm going to have a slightly shorter rain barrel here. I'm actually cutting the top off, so it's probably 52 gallons, maybe short of 55 gallons underneath. And I've designed a cam assembly, which I'll talk about in the next video, on how to very easily remove the bin, empty it, and replace it. Again, the cart that was in my original dust collector used to be a lot wider, and I've cut it off, and so it's much shorter. I've added larger diameter casters to it, and they are all swivel casters on all of them, so it's easy to negotiate around in my shop. Here's the right view showing both of the filter cartridges in it. And by the way, I didn't make a point. This is about 86 inches tall to the top of the motor, so definitely fit within an 8-foot ceiling, and it just is a little too tall to fit if you have a flat ceiling at 7 foot. But you can always cut the bin shorter if you really have to fit underneath a 7-foot ceiling. And here's the unit before I painted it with the 2 horsepower blower at the top, and we see the input pipe coming here, the ramp coming down, and I'm going to talk about the ramp that I put inside the cylinder to help facilitate that downward motion. The Lexan cylinder here, and I have the bin here, the cam assemblies for lowering and emptying the bin, the 2 cartridges at the right connected to the plenum, and I've also added 2 Dwyer magnehelic gauges on it. This one tells me the back pressure of the filters, and this one tells me the static pressure of the input side, so I know when I connect up to a machine roughly how much airflow I'm getting, and I get all that data based on the testing, which I'll get to in a later video. Okay, these are roughly the dimensions that I have for the cylinder, the Lexan cylinder. It's roughly about 19.5 inches in diameter, and again I'm using 20 staves for that, and I'll get to that here in a minute. I've made the thing about 22 inches tall, and I wanted to test it to know how close I could get the exit pipe to the Thien baffle plate in it. So I don't move this, but I actually move this pipe up and down in the testing to determine the optimum place for putting that. I have a 2-inch perimeter slot here around the perimeter, and I think that's a little wide. I think it's actually 1.5 inches I ended up making around the perimeter for that. And what else do I have here? Oh, the spiral ramp. I want it roughly about 10 inches down per 360 degrees rotation, so that determined the slope of the input chute that I have. And I found this website here, and it's a tool that allows you, actually it's for making drums, for staves for a drum, but you can use it for other things too. And I used it in this case to determine the angles on each of the staves, which is a total 18 degrees or 9.5 degrees angle on each of the ends of the staves. So I was able to cut that. And again, I'm using 1/4 inch polycarbonate or Lexan for that. I've also used this weld-on adhesive for the IPS 16, and I actually didn't use an applicator. I just used the 16 for gluing the polycarbonate together. Now, if you don't really want to make your own cylinder, there are alternatives, and I've looked around at various things, whether it's a concrete a post mold from Home Depot. Couldn't really get one, you know, about 18 inches or more in diameter easily, but over in the plumbing section, Home Depot sells these sump pump basins, which are almost ideal for the size of the cylinder that I used. And it is slightly tapered with open end and a bit wider at the bottom, or at the top here in this case. However, I would probably, if I use this, I would mount it upside down, and you could either cut off the closed end or just drill a hole in the side for your input chute to come in. And they're reasonably priced. They're about $24 last check from Home Depot. And I've listed the SKU number here if you're interested in using that. But I'm funny. I really wanted to see the dust swirling around in there and just get mesmerized by it. So I did not use this, but really seems like a slick alternative. Another alternative is you can buy just clear polycarbonate sheets. In this case, it might be a little bit thin, but it's bendable at room temperature for radiuses greater than 19 inches. So if you want to form it at 19 inches, you can use this sheet. It's a bit pricey. It's $100 from Home Depot. Again, I've included the SKU number here for that if you're interested. And it's plenty tall enough. You could cut it down to the 22 inches for the height of the unit that I built here. Okay, so I started with the cylinder, and this is the I actually glued things or taped things up with painter's tape first to see how it would fit together. Then I didn't glue all the joints at once because this glue sets very quickly, and I stand corrected. I use the IPS 16 fast setting glue for doing that. So I glued 4 joints at a time, in other words every 5th joint, because I've got 20 of these staves in here, and then quickly rolled it into a cylinder after the glue is applied, and then let it sit for a couple hours, then move on to the next set. Couple things I learned from this that I would probably do differently is this one set of old Lexan I had here, the film coating on it is very flimsy and some of the glue leaked underneath of it. I'd probably take it all off and just apply the tape on it to try to keep the glue from seeping in. So you'll see when we get it finished up here that some of the joints are a little smeared because that glue went underneath. So once it's all together, in fact you can see one here, it's a little bit smeared here, but for all intents and purposes it works just fine. I can still see things in there. So I put the cylinder here and I cut a hole out to match it in the bottom plate, and then cut a groove or a dado to match it in the top plate to fit it all together there. Then I cut a hole in the top to mount the 6-inch sewer and drain pipe which I used for this dust collector. I didn't use the Schedule 40, used the thinner sewer and drain pipe for this. So it's coming along here. Next, I built the input chute, and it starts straight and then curves down some here to give me that bend that I wanted. And I also coated the input sides. I had some leftover countertop Formica that I bought at a yard sale probably 30 years ago, and I just cut some pieces on that to hopefully reduce the wear and tear on that. When I was all done with this, then I took the screws out and I put some silicone caulk along that edge and then screwed them back together. Now comes the tough part, is trying to figure out what slot to cut in the side of that cylinder that you just spent so much time working on to insert the chute in. And I actually had it mounted up top, so this is actually the bottom of the chute, so I could measure where I needed to cut. And my first measurements were incorrect. I was off, and this is one of those things, boy, you want to double and triple measure before you cut, because you don't want to mess it up and have to start on the cylinder all again. And so once I got it all marked up, then I cut or drilled I think it was probably about 3/8 inch holes in the corners where it's going to go to help relieve stress in that, because you don't want a perfectly straight corner. It could get some stresses and crack on there, so I left a little bit of radius on those. Then I came in with a fine-tooth jigsaw and cut that out. Then I measured it here. The one last step to do for this is once this bottom part of the cylinder meets the bottom part, or the cylinder here meets the bottom part of the chute, I want to cut a dado in there so it fits down in it and gives me a very nice seal. So I went ahead and marked that and did that, and you can see the cutout here. And by the way, I did place painter's tape on both inside and outside to help reduce any chipping that might occur when I was cutting that out. Next step is I want to put a spiral plate ramp in it. And the question is, how do you do that? At first I tried using 1/8 inch hardboard, and it just didn't work. It just couldn't get it to physically bend and keep the shape, and it just wasn't working right. Again, it's roughly about 19.5 inches in diameter to fit the inside of the cylinder, and then I wanted the 6-inch hole in the center, and it's actually 6 inch plus a little bit because the diameter of the pipe is, I think, about 6¼ inches, and it just couldn't get that 10-inch bend in it with this thin plate here. So what came to mind was, years ago I made a whirligig out of thin pieces of stock and just spiraled them out. I said, well, why can't I do that here and then cut the center out when I'm all done for the pipe? So that's what I did, and I put the ramp together in here. I calculated how far the pieces needed to be offset here to give me roughly 10-inch ramp for 1 degree or 360 degree of rotation. So I did that, and then you can say, okay, well that's going to be rough. Well, bear with me. We'll get to that here in a minute. So we got the ramp completed here, all glued up, and I just used a 1/4 inch all thread to put it together, and I did them in steps, did them 4 at a time, and just kept gluing them up and putting it in. Then I rough cut out the center for the pipe, and I had to work on that a little bit, and it's a little bit of a challenge to get the jigsaw in there to cut it out, and then I had to use my rasp and my files to get it so it actually fit right. The outside was a little bit easier to get it fit inside the cylinder, which by the way, wasn't 100% round. It was slightly out of round, and it probably would have been better if I would have made a form to wrap the staves around right after I glued it to try to keep it more in a circular shape. It wasn't out around by much, but maybe about 1/8 of an inch. So here I have it now fit inside the cylinder, got it all there, and then around the pipe. So that looks like it's going to be great, with one exception. The air's flowing this way, and that's a rough surface to do that. So how do we deal with that? We're going to go ahead and smear some auto body filler and on there and try to smooth that out. I didn't care about the top side because the air isn't flowing on the top side, but the bottom side, really want that smooth. And I tried to take a chisel and try to flatten it a little bit just before the auto body really the filler really set up nice, and you can work it a little bit. Then shortly thereafter I went to it with my random orbit sander to sand it smooth, and there we have it all smoothed out, ready to go. So with that, I didn't want to leave it to just bare like that, so I went ahead and primed it and painted it green, and so it could fit right up inside there. I also applied then over the paint, I applied 1 coat of resin like you do in fiberglass, auto body fiberglass, hopefully to help prolong the paint and that the debris wouldn't wear the paint away. So just try to protect it a little bit. I also added these little fastening pieces of wood here at various places around that then I can screw it from the outside of the cylinder to hold the ramp in place. And this is with the ramp installed, but before I painted it. And I've also, you'll see here, I've also added columns to help hold the top plate and the bottom plate all together, and we'll talk about, I also screwed the bottom, and I've got a picture on that here in a second. Yeah, so at the bottom plate I went ahead and put a screw in each of the staves, and you had to be a little careful because my circle was out around just a little bit, so you don't want to really tighten them down too much if there's a gap between the stave and the plate. Then I also ran screws up into the posts that I had mounted there. And there's the cylinder and chute assembly complete, ready to go. Now there's a couple things that we're going to need to do yet on this, and one of it is there's a gap here that we need to fill in, plus the gap on the other side of the chute where it meets the cylinder. I probably could have just caulked it, but I wanted to try to get a little bit more stability in there, so I'll talk about that here. In fact, here it is. So this is the side of the cylinder, and this is the left side of the chute. And so I made a little bracket piece in there that would fit right in there and angle up, so it would meet the angle of the cylinder and the angle of the chute assembly. Once I got it in place, I caulked both sides. I painted it first, then I caulked both sides and screwed a couple screws from inside the chute and from inside the cylinder to hold that in place. Then I went through and I could caulk the outside of that too. On the other side of the chute, we had this triangle piece here, and I cut a piece to fit in there, and then I caulked that after I painted it. I caulked it and then screwed it down from the top of the plate to hold that in place. And then I went through and I caulked all the joints on this. Now, the first time through, before I really finished all the painting, you'll see there's blue painter's tape along the bottom of the cylinder, and I used that just for testing, just to seal it up temporarily. When I was all done and did some testing, I went back and actually disassembled most of it and completed the painting on all of it. And that completes part 2. I thank you for watching, and on part 3 we'll talk about the rest of the unit for the framing pieces and the cams for raising and lowering the barrel and the mods to the barrel that I did. So with that, thank you for your time. Have a great day.